Good evening from NASA's Kennedy Space Center in Florida. I'm Stephen Clark, the editor of SpaceflightNow.com, and welcome to our live coverage for the scheduled static fire test of SpaceX's fourth Falcon Heavy rocket. You're looking at a live view of the Falcon Heavy on the launch pad at Launch Complex 39A here at Kennedy, where we're about 40 minutes away from the expected ignition time of 27 Merlin engines, 9 on 3 different Falcon rocket cores bolted together out at pad 39A. The Falcon Heavy will be remaining on the pad this evening. Hold down clamps on each of these booster cores, 3 of them together, will be holding the rocket firmly on planet Earth tonight as the 27 Merlin engines light up for nearly 10 seconds. We expect to see these engines burn tonight. This is again a static fire test in preparation for the scheduled launch of the Falcon Heavy rocket next week. Right now, that liftoff is targeted for no earlier than Tuesday, November the 1st, in a launch window that opens at 9:40 a.m. Eastern Time, or 13:40 UTC. Again, tonight's static fire test now a little more than 39 minutes away. Ignition time is scheduled for 8 p.m. Eastern Time, that is midnight UTC. And as you can see, we're seeing the first signs of vapors around the 3 Falcon Heavy booster cores as propellants are loaded into the vehicle. That propellant loading, we believe, got underway at about T-minus 50 minutes, a little more than 10 minutes ago. The propellant loading sequence is a bit different for the Falcon Heavy rocket than it is for a Falcon 9 mission, which a Falcon 9, of course, is one single first-stage booster. Falcon Heavy is made of 3. For a Falcon 9 mission, the propellant loading begins at T-minus 35 minutes. And for a Falcon Heavy, that begins at about T-minus 50 minutes, so about 15 minutes longer to fully load propellants into a Falcon Heavy rocket. The sequence we expect began with the loading of rocket-grade kerosene, that's known as RP-1 or Rocket Propellant 1, into the 3 first-stage booster cores at 50 minutes. And then at T-minus 45 minutes was the expected time for the start of liquid oxygen loading. This liquid oxygen is chilled to several hundred degrees below zero. And again, the name oxygen hints that it's the oxidizer used by the 27 Merlin engines during their ignition and burn. So both propellants currently are being loaded into the Falcon Heavy rocket, evidenced by the vapors you see building up around the skin, the outer airframe of the booster core there. Coming up at T-minus 35 minutes is when we expect SpaceX to begin loading kerosene fuel onto the second stage. And then at T-minus 18.5 minutes, we expect liquid oxygen to begin loading onto stage 2. So a bit different countdown sequence than a typical SpaceX Falcon 9 countdown tonight. But this is all culminating in the scheduled ignition of 27 Merlin engines at 8 p.m. Eastern Time. That is midnight UTC for those of you in other time zones. We saw the Falcon Heavy roll out to pad 39A back on Tuesday night. It was scheduled to be raised vertical for a static test firing yesterday, but that did not happen. SpaceX was working some sort of technical issue that delayed the lifting of the rocket vertical, and as a result delayed the static fire test from yesterday until tonight. And that has continued to impact the schedule going forward for this mission, delaying the scheduled launch from Monday morning to Tuesday morning, local time here in Florida. You'll notice that the payload fairing for this Falcon Heavy rocket is not on the vehicle. SpaceX, as is customary for most of their missions where they perform a test firing, is doing this test without the payload attached. So the satellites for the U.S. Space Force that will be flying this rocket into orbit are not on the vehicle for tonight's test. They are being integrated off-site and encapsulated. They should now be encapsulated inside the payload fairing of the Falcon Heavy, and they'll be transferred to the hangar at pad 39A sometime in the coming days for integration with the rocket. Once this static fire test is complete, if everything is satisfactory and SpaceX gives a thumbs up on the result of the test, the rocket will be lowered back horizontal and rolled back to the hangar for integration with the payloads. And we expect the rocket to return to pad 39A sometime late this weekend or perhaps on Monday, lining up for the launch attempt on Tuesday morning. Now around 35 minutes remaining until the expected ignition time for this static fire test. If you haven't had a chance to do so yet, please hit the like button here on our YouTube stream. Please hit the like button because that really helps us gain a larger audience for our coverage. We want to bring this to as many people who may be interested as possible. This is the fourth Falcon Heavy rocket that SpaceX will be launching. It follows an inaugural test flight back in February of 2018 that famously carried one of Elon Musk's Teslas into heliocentric orbit on an Earth escape trajectory. That was a demonstration flight. And then SpaceX has launched 2 Falcon Heavy flights for customers in 2019, one for the Saudi Arabian company Arabsat with a communications satellite, and then another mission for the U.S. military carrying a cache of technology demonstration and experimental satellites for the Department of Defense and also for NASA on the STP-2 mission. That's the Space Test Program number 2 mission. That launched back on June the 25th of 2019. So nearly 3.5 years have elapsed since the most recent Falcon Heavy flight. The reason for that long gap in flights has been related to the readiness of payloads assigned to Falcon Heavy missions. Multiple payloads for multiple Falcon Heavy rockets have run into technical problems and also some supply chain issues stemming from the COVID pandemic. This particular mission that's scheduled for launch next week is designated USS F-44, United States Space Force 44. This mission was originally contracted to launch on a Falcon Heavy in late 2020. So this mission alone has run into a 2-year delay. Other payloads that are booked on Falcon Heavy missions, such as Viasat-3 internet satellite, as well as NASA's Psyche asteroid explorer, have also had technical delays and have had their launches delayed from this year, likely into 2023. We don't expect as long of a gap between Falcon Heavy missions going forward. After this one, there's another Falcon Heavy launch scheduled in January. And SpaceX recently said they have 6 Falcon Heavy launches booked over the next 12 months or so. 3 of those are for the U.S. Space Force. 2 of them are for commercial customers, and 1 is for NASA. So we've passed the 35-minute mark a couple of minutes ago. So propellants, fuel at least, should be flowing into the second stage at this time. As propellants, both commodities, liquid oxygen and kerosene, continue to be pumped into the 3 Falcon Heavy boosters. About 3 million pounds of propellant will be loaded into the Falcon Heavy rocket tonight in preparation for this test firing at 8 p.m. Eastern Time or midnight UTC. We're now inside of 30 minutes until the expected time of engine ignition for tonight's Falcon Heavy test firing at Pad 39A at NASA's Kennedy Space Center in Florida. You can see more vapors are building up around the 3 Falcon Heavy boosters. All 3 of the Falcon Heavy booster cores for this particular mission are brand new, so they're each making their first flight. SpaceX intends to recover the 2 side boosters back at Cape Canaveral Space Force Station, about 10 miles south of Pad 39A, with a return to launch site landing. So these 2 boosters will actually fly themselves back to Cape Canaveral after the launch next week, landing at Landing Zone 1 and 2, SpaceX's 2 landing pads at the Cape, about 10 minutes or so after liftoff. The center core, the central booster, will actually be expended. It'll be the first Falcon rocket booster intentionally expended in some time, a couple of years. That's because the mission profile for this flight of the Falcon Heavy demands that the center core devote all of its propellant to powering and propelling these Space Force payloads into orbit. There are multiple satellites on this mission for the U.S. Space Force. Not a lot is known about them, but we do know they're heading into what's known as a geosynchronous orbit. That's about 22,000 miles or about 36,000 kilometers over the equator. And this will require the Falcon Heavy's upper stage to perform a coast between engine burns, lasting about 6 hours. So it'll take more than 6 hours for the Falcon Heavy to deploy all of its satellites into that circular low-inclination equatorial orbit, more than 20,000 miles above Earth. This will be one of the most demanding SpaceX mission profiles to date. It'll be the first time that SpaceX has flown a mission that's lasted more than 6 hours from launch through payload separation. And one of the modifications to the rocket to make this possible is a gray band. This is a band of gray paint or insulation around the circumference of the kerosene tank on the second stage of the Falcon Heavy rocket. If you look closely, you may be able to see that near the top of the rocket. That is there to help ensure the kerosene fuel does not freeze during the long 6-hour coast through the cold environment of space. They want to make sure that propellant, that fuel, is properly conditioned to flow into the upper stage engine when it needs to relight to do the final maneuver to place these payloads into a near geosynchronous orbit. We've passed about 27 minutes now remaining until engine ignition time. That remains targeted for 8 p.m. Eastern or midnight UTC. We've now passed 25 minutes until the expected time for tonight's static fire test here at NASA's Kennedy Space Center in Florida. You're looking live at SpaceX's Falcon Heavy rocket standing vertical out on the pad. No payload on the rocket for this particular test. The payload is being prepared at another facility here at the spaceport and will be integrated with the rocket after this test firing is completed. Again, this rocket is being prepared for launch on a mission for the U.S. Space Force. This is actually the first Falcon Heavy launch with a dedicated flight for the U.S. Space Force's National Security Space Launch Program. This program, also known as NSSL, provides launch opportunities for the military's most expensive and most critical national security payloads. I mentioned the Falcon Heavy flew a military mission back in 2019, but that was a mission dedicated to launching technology demonstration satellites for the military and NASA, and was contracted through a different program with a different set of requirements. But the National Security Space Launch Program is really the bread and butter of the Space Force's launch enterprise, responsible for arranging launch services for the most sensitive, most costly, and most critical national security satellites. The payloads on this mission we don't know a lot about. As I've said, the Space Force is keeping those details close to its vests for now. We know there's one microsatellite on board named Tetra 1 that's testing some technology, some microsatellite technology for future use on future operational satellites that could be flying in geosynchronous orbit. We do hope to report more details on the payloads on this mission leading up to the launch. We've asked the Space Force for some details, and we hope to provide those in a story on our website, spaceflightnow.com, in the coming days. I want to give a big thank you to those of you who have contributed here in the Super Chat. Thanks to Joe Henson for his donation just now. That really helps and is much appreciated. You can support our coverage by becoming a member of our Spaceflight Now YouTube channel. If you join there, depending on which membership level you choose, you can gain access to exclusive bonus members-only video features, and you'll be supporting our coverage, helping us bring you live events like this one. You can also contribute there in the Super Chat, as we've seen a couple of you already do, so a big thank you to those of you who have already done that. Also, if you haven't done so, please subscribe to our YouTube channel. You can do that for free and get alerts every time we're going live with any live streaming or live commentary. And also hit the like button on our YouTube stream here. That helps us gain a larger audience for our coverage. We've just seen in the last minute or so the start of the big vent from the Strongback out at Pad 39A. This does occur a couple of minutes earlier than it typically does for a Falcon 9 launch. It usually occurs at about 20 minutes. We saw this vent begin at about 22 minutes or so before the scheduled ignition time. That's because the liquid oxygen load on the second stage actually begins 2 minutes earlier in the countdown for this Falcon Heavy launch, or this Falcon Heavy static fire, than it does for a Falcon 9 countdown. So there are some small changes in the timeline for a Falcon Heavy launch as opposed to a Falcon 9, which you may be accustomed to watching. But the major events that the countdown needs to accomplish are the same. They got to load the liquid oxygen and kerosene into the vehicle. And then in the final 7 minutes of the countdown, they'll chill down, thermally condition the Merlin engines on the first stage cores. And then at T-minus 60 seconds is when the propellants on board the Falcon Heavy should begin, propellant tanks on board the Falcon Heavy should begin to undergo their final pressurization steps to get up to flight pressure. And then the engine ignition sequence is expected to begin around T-minus 2 seconds. Countdown is approaching T-minus 19 minutes. We saw that big vent began about 3 minutes ago. The vent of oxygen, vapor, and gas from the strong back out at pad 39A coincides with the start of the chill down of the liquid oxygen transfer line that leads from the ground systems at the pad surface up to the strong back mast to the level even with the second stage of the rocket. SpaceX wants to make sure those transfer lines are chilled down and brought down to the cryogenic temperature before pumping liquid oxygen into the second stage. That loading of liquid oxygen should begin momentarily, and we expect to see that vent terminate when that begins. And we have seen that vent terminate, and that is an indicator that liquid oxygen has started or is about to start flowing into the second stage. SpaceX fully loads the rocket with propellants. This is a full-up simulated countdown. So they're loading propellants into the second stage, even though the second stage won't be operated, won't be ignited, obviously, on tonight's test. SpaceX's launch team is stationed in firing room number 4 at NASA's Kennedy Space Center at the Launch Control Center, right next to the vehicle assembly building. That's actually just across the road from where I'm reporting from this evening at Kennedy Space Center, about 3 miles from pad 39A. SpaceX's countdown has just passed 13 minutes until the ignition for tonight's static fire test. We expect the static fire to last between 5 and 10 seconds. 7 seconds is a standard duration for a static fire, although that can be adjusted a bit. So about 5 to 10 seconds, we expect to see the engines burning tonight. That will be enough time for the Merlin engines to power up to full throttle. The 27 engines will be generating about 5.1 million pounds of thrust at full power. Now at T-minus 12 minutes and counting. In this close-up view of the Falcon Heavy, you can see more venting now visible around the upper stage area at the top of the rocket as liquid oxygen is flowing into stage 2 now. And if you look closely, you can see that gray band painted around the circumference of the second stage kerosene tank. I mentioned that a little before. That's to provide some insulation for the kerosene inside that tank for this Falcon Heavy rocket's 6-hour flight from the launch pad here in Florida to a near geosynchronous orbit about 22,000 miles over the equator. This will be the longest duration flight SpaceX has ever attempted from the time of launch until deployment of a payload into orbit. Again, this mission is set for launch next week with multiple payloads for the United States Space Force. The mission is designated USSF-44. Now 10 minutes remaining until tonight's test firing of the Falcon Heavy. As we get into the final 10 minutes of the countdown, we'll ask you one more time to please hit the like button here on our YouTube stream. That helps us gain a larger audience for our coverage. In the next few minutes, at T-minus 7 minutes, we expect engine chill down to begin on the 27 Merlin engines. This will involve flowing small amounts of liquid oxygen through some of the engine plumbing to thermally condition those components for the more rapid flow of propellant at engine start. This helps ensure that the engines aren't damaged by the sudden rush of super cold liquid oxygen. T-minus 9 minutes. T-minus 7 minutes, and we're now 7 minutes away from the static fire test for SpaceX's fourth Falcon Heavy rocket, which you're looking at a live view of right now at NASA's Kennedy Space Center in Florida. At this point in the countdown, the engine chill down should now be underway. This is that thermal conditioning step I mentioned a few moments ago for the 27 Merlin engines on the 3 Falcon Heavy first stage booster cores. Also at this point in the countdown, in the next minute or so, the RP1 kerosene tanks on the second stage, well, the second stage tank should already be full, but the 3 Falcon Heavy first stage boosters should have their kerosene tanks fully loaded in the next minute or so as the countdown approaches T-minus 6 minutes. It's a nice shot from the Kennedy Space Center press site, the flags waving in a light breeze this evening. Off to the right from the Falcon Heavy rocket is the Starship launch pad tower that was built up over the summer to support future launches of SpaceX's next generation Super Heavy and Starship rocket from Kennedy Space Center. But tonight's action is the Falcon Heavy, which remains the most powerful operational rocket in the world. Again, it can produce 5.1 million pounds of thrust from its 27 main engines. And if flown in a fully expendable mode, devoting all of its propellant to lifting a payload into orbit, it can haul about 140,000 pounds, or about 64 metric tons, of cargo into a low Earth orbit. That is the most capable performance, lift performance into low Earth orbit by any currently flying rocket by some measure. The countdown is now approaching 4.5 minutes. The next thing we expect to see out at pad 39A is the retraction of the strongback. That should recline to an angle of about 1.5 degrees from the Falcon Heavy in the next few moments. You can see that strongback has retracted. Now 3 minutes remaining until ignition of the Falcon Heavy's 27 Merlin main engines. Everything looking right on track right now for this 8 p.m. static fire test, 8 p.m. Eastern Time, or midnight UTC. Now 90 seconds remaining until tonight's static fire test. You're continuing to watch a live view of Pad 39A at NASA's Kennedy Space Center in Florida. SpaceX's fourth Falcon Heavy rocket, now about a minute 15 seconds from igniting its 27 engines for this static fire test. Again, no launch tonight. The Falcon Heavy will remain on the pad, held down by clamps, hydraulic clamps, as the Merlin engines fire for what we expect to be between 5 and 10 seconds. This is a key test before the launch next week for the U.S. Space Force, now inside of 60 seconds. 45 seconds now until ignition time. These 27 Merlin engines will generate more than 5 million pounds of thrust. More than any other rocket currently flying in the world, inside 30 seconds now. T-minus 15 seconds. We're going to stand by for engine start. We have engine start on the Falcon Heavy rocket. 27 engines firing, we believe. And shutdown. That appeared to be a good static fire test. We're now hearing the rumble. A big loud rumble passing through Kennedy Space Center. We're about 3 miles away from the pad. We felt that when 27 engines firing from the Falcon Heavy. And that did appear to be a full duration test. Of course, we'll stand by for confirmation from SpaceX, which typically comes in the hours after a static fire test, that the test was successful. But visually, that looked exactly like what we expected to see tonight for the Falcon Heavy static fire. Just to recap what we've seen this evening, we saw the static fire test of SpaceX's fourth Falcon Heavy rocket that occurred at 8 p.m. Eastern Time on the dot. That's midnight UTC, about 9 minutes ago. The Merlin engines fired for 5 to 10 seconds. We saw that plume of exhaust come out of the flame trench on the north side of the pad, and we heard a very loud rumble from our location about 3 miles away from the 27 engines on the Falcon Heavy. In fact, it shook the roof that we're on here at Kennedy Space Center. We expect to hear from SpaceX hopefully later tonight on the confirmation of the outcome of this test. Visually, it did appear to be a successful test. It hit the planned duration, we believe. But SpaceX engineers will be reviewing data from all the systems, both on the vehicle and the ground systems out at the pad, to make sure everything worked perfectly. Again, this is the first Falcon Heavy that has launched in 3.5 years. So they want to make sure everything is working as expected with this rocket. And if everything is cleared and good to go, SpaceX will lower the Falcon Heavy rocket back horizontal, likely sometime late tomorrow, based on the standard timeline, and then roll it back into the hangar for integration with its payload. Of course, this is what we colloquially call a headless rocket. There's no payload fairing on this vehicle for tonight's static fire test. That will be attached in the hangar in the coming days. And then once the Falcon Heavy is fully integrated with its payload fairing and its U.S. Space Force satellite passengers, the rocket will be returned to Pad 39A late this weekend or very early Monday, if the schedules hold, in preparation for a launch attempt no earlier than Tuesday, November the 1st, with the window opening at 9:40 a.m. Eastern Daylight Time, or 1340 UTC. We will, of course, be covering the launch next week of the Falcon Heavy. We'll have a live stream on here on YouTube, on our YouTube channel. We'll also have extensive coverage on our website, spaceflightnow.com, so be sure to check that out, including some new details about some of the payloads that'll be this rocket will be carrying that we've just received tonight. We hope to be publishing a story on that tonight or tomorrow, so check that out if you're interested. We're going to conclude our stream here, our live commentary stream on YouTube now, but we'll continue showing live views on our separate stream that we're going to post in the chat here on our YouTube channel here. We'll have 24/7 views of Pad 39A over the coming days. We'll catch the Falcon Heavy as it's lowered horizontal and returned to the hangar. And then we'll be able to see the Falcon Heavy as it makes its way back to the pad with its payload attached in the next few days. So be sure to check that out with our 24/7 live view of the Launch Complex 39A here at Kennedy Space Center as SpaceX takes the next steps to prepare for this launch next week. We'll also be covering the launch of a Falcon 9 rocket. SpaceX teams out at Vandenberg Space Force Base in California are gearing up for a Falcon 9 launch in about an hour's time at 9:14 p.m. Eastern Time, or 6:14 p.m. Pacific Time. This Falcon 9 mission will deploy 53 more Starlink Internet satellites into orbit for SpaceX's global broadband network. Again, this launch from out at Vandenberg Space Force Base on California's Central Coast is about an hour away now at 9:14 p.m. Eastern Time, or 6:14 p.m. Pacific. That is 1:14 a.m. UTC. We'll be covering that live with our live blog updates and SpaceX's live stream embedded on our Mission Status Center at spaceflightnow.com. So join us 1 hour from now for that launch as well. So until next time, I'm Stephen Clark, editor, spaceflightnow.com, reporting live from NASA's Kennedy Space Center in Florida. We'll see you next time.